Hello there. In this tutorial we'll be taking a look at three automated model selection procedures. These are the forward method, the backward elimination and stepwise methods. The forward method starts with the simplest model of all and adds suitable variables one at a time until the best model is reached. The backwards method works with the most general model and drops variables one at a time until the best model is reached. The stepwise procedure is a combination of backward and forward methods where variables can be dropped and added. In all three methods in R, the AIC is used as the criteria to select the model. The rule is the lower the AIC, the better the model. Here we have a data set of prices for electricity used for different purposes in states of the United States of America. We'll use the first four variables to model I-2005. Let's consider first the backwards elimination method. The command we need is step, followed by LM for linear model, followed by the name of the DV, tilde, and then a list of all the IVs we're considering. And the data we're using is called elect. Then we state the direction, which is backward. Here is the output. There seems to be a lot of it, but in fact the one that is useful is the final thing at the bottom. This block here tells us the final model reached from the one which we started from. So you see that the final model includes an intercept, the variable R2004 and the variable C2005. Let's have a look at the intermediary steps. In this line you see the full model. It has an AIC of 18.26. Now look at this block here. This first row says that if I were to drop C2004, then the refitted model would have an AIC of 16.269. This is a fall from 18.26. So it means that the model, if we drop C2004, is better than the one we started out with. The next line says that if instead of dropping C2004 I dropped R2004 and refitted the model, the AIC would be 16.333. Again, this is an improvement on the original model. However, it is not as good as dropping C2004, which leads to a new model with an AIC lower at 16.269. So if we look down the column, you can see that the AICs increase. So it seems like the best thing you can do is to drop C2004. And this is what actually happens in the next step. So you see the revised model is now includes three explanatory variables. C2004 has been dropped. This refitted model has an AIC of 16.27, which is pretty much this number. And so it goes on. And this time you're asked whether to drop R2004, R2005, C2005. And the similar story applies. If we drop R2005 and refit the model, we have an AIC, a lower AIC of 14.462. And again, since this is lower than all the other values in this column, it means that we're best dropping R 2005. And this takes us now to a model where we have two explanatory variables. And again we ask the same question, can I do better? If I drop R 2004, I have a AIC of 16.597, and an even higher one if I drop C 2005. This compares to an AIC of the current model of 14.46. In other words, we can't do better by dropping any other variable. And so we have reached an end and conclude that the best model is one where we include the variables R2004, C2005. And here are the estimates. Now for the forward method. So the forward method, we start off with just an intercept in the model. So again the command is step, and you see here that we're now regressing on the intercept. That's denoted by the 1. Data equals, and then the name of our dataset, direction forward, followed by scope. So just type in scope equals tilde and then make a list of the variables. All 4 variables. Enter. Again, the bottom line tells us the final model we end up with. And if we look at the intermediary tables, it's similar to before, but this time we are, notice, we are adding, not subtracting. So again, if we go through the same analysis, if we add C2005, we end up with a revised model with a low AIC, 16.597, and this is lowest in this column, so it is the best one to add to this model, which current model, which has only an AIC of a massive 87. And so we go on and on and on. Last but not least is the stepwise method. This is where model variables can be added and taken away from the model. Now you can start the stepwise procedure with either the smallest model or the largest model. Again, just to take you through the code, it's the step command lm. This time we're starting off with all the variables. The key thing to tell are that we are using stepwise is the direction, which we state to be both. Okay, well, that ends the tutorial. Why not give it a go? That's all for now. Bye bye.